Hello, in this video I will show you how to simplify resistances as seen by two terminals on CircuitsU. First things first, we need to first know where our terminals are, and in this case we have our two terminals here. When it says by looking into the indicated terminals, we are referring to these open terminals in which we will quote-unquote look into the circuit to obtain the equivalent resistance. So another thing to mention is that we can see here that the terminal of this 2 ohm resistor is directly connected to the terminal that we want to take the resistance from. Same thing with the 30 ohms. So we need to be very mindful which resistors are connected to the terminals themselves, because we know that those are the last ones that we will simplify. Because we want to go from the farthest resistors from the terminals to going our way back into the terminals. So same thing as we've seen before is to identify the farthest resistors from the terminals. So in this case, we have the 3 ohms and the 2 ohms, whichever you want to do is your choice. So this 2 ohms is this one here, and then this 3 ohms. I think I will choose the 3 ohms first to combine with the 12 ohms. So the next thing that once we have identified our farthest resistor is to identify the resistor right next to it. So in this case, the resistor right next to it, so resistor or resistors right next to it, is the 12 ohms. And then we need to know which position or which connection they are sharing. So in this case, whether if the connection is series or parallel. So this 3 ohms is the terminals of the 3 ohms are here, right? So right next to the 3 ohms, closest to it is the 12 ohms here. And these 12 ohms resistor has the terminals here. Now notice that the terminals between the 3 ohms and the 12 ohms are shared here, but the other terminal on the other side, they are not shared. They are shared by another resistor, which in this case is the 30 ohms. So this means that our connection between the 12 ohms and the 3 ohms is in series, because connections in series only share one common terminal among them. So in this case, it's going to be 3 plus 12, which is going to give us 15. So that's our first thing. Now let me clear all the drawings, and then I will go into CircuitsU to combine the 3 and the 12 in series. So I will select the 3, select the 12, combine in series. Then, since they're in series, we need to replace one of them with a short wire so as to keep the circuit as it is. So either way, whether it's the 3 or the 12, doesn't really make too much of a difference, because they are in series. You can just swap them. So I will replace the 3 ohms in this case, let's say, with the equivalent resistor, which is going to be 15. And since the connection is in series, we're going to have a short circuit. So I will submit, and then it is correct. Now, since I'm already on a roll, in this case, what we want to do here is the 15 ohm resistor is already identified as being the farthest away, same with the 2 ohms, but we're still going to do it with the 15. And then the resistor right next to it. So same thing, we go with the same steps. Identify farthest resistor. Identify the resistor next to it. Then check which connection. Now, in this case, the connection is going to be parallel. How do we know that it's parallel? The way that we know that it's parallel is if we were to draw the terminals of the 15 ohm resistor, let's say here, and the terminals of the 30 ohms, which are here, which also conveniently are also shared by these terminals. Notice here that these form the same node because only wire is between them, so they are the same. And even then, if we combine those two resistors in parallel, it will not change the place of the open terminals in which we're trying to calculate the resistance. So that will be, this will be valid. So in this case, these two resistors share the same terminals, both of them. So if they share both of their terminals with each other, then the connection is parallel. So we're going to simplify the 30 and the 15 with the product over the sum. In this case, is going to be 10 ohms because 30 times 15 is 450 over 45 is 10 ohms. So now the next thing is to select. Let me change to a cursor. We're going to select these two resistors, the 30 and the 15, and since they are in parallel, we need to replace one of them with an open wire so as to simplify the circuit. It doesn't really matter which one. So what I will do is I will just replace the 30 with an open circuit, and I will put here 10 ohms and then the 15 ohm with the equivalent resistor. So that's how we simplify. And then once we do that, we have the correct answer. Then let's go to the left side. So we have these, we know that these two are in series, so we can combine them also, right? So these two terminals, only one of them is shared. The other one is not shared among them, so it's series. We can go that way, or what I will do is I will just combine these two in parallel. Again, what do we know? How do we know they're in parallel? If we were to draw both of the terminals here, they both share their terminals, so they are in parallel. So 2 in parallel with 2, which is equal to product over the sum. So it's 2 times 2 over 2 plus 2, which is 4 over 4, which is 1 ohm. So then we can combine these two resistors in parallel. Either one of them will be replaced by an open circuit because they are in parallel, so one of them has to be open, and we'll replace the 2 with 1. So then we submit, and it is correct. And then finally, we can get rid of, not get rid, but we can simplify all these three resistances by combining them in series. Now, why are they in series? Remember, these terminals, if you've been looking throughout the whole video, they do not ever change their place at all. They'll always be fixed. So no matter what combinations you do, what simplifications you do, those two terminals are going to be the same. So in this case, this 1 ohms is in series with this 1 ohm because only one of the terminals is shared. This terminal and these terminals, they are not shared by the other 1 ohm. Then this 1 ohm terminal shares with this 10 ohm, but this other terminal is not shared by the 1 ohm, right? So if only one terminal of the resistor is shared among the resistors, then they will be in series. So it's this one and then this one. So then the resistance will be 10 plus 1 plus 1, which is 12 ohms. So I hope that I have made the point clear with why the resistors are in series. So now we're going to select these three. We will combine in series. We need to get rid of the other two resistors by replacing them with wires because they are in series. So we will just use, let's say, the ones with the short circuit and the 10 with the equivalent resistor, which is 12. And then I will submit the answer. And voila, here's our final resistance, which is 12 ohms. So hopefully with this video, I have shown you a clear method and steps on how to simplify resistances as seen by two terminals. If you have any questions, if you have any comments, please let me know. And yeah, thank you very much for watching and keep practicing.